観測衛星アリティア L1 は2日に地球からインドは先月、世界で初めて月の南極付近に無人探査機を着陸させたばかりで、来週ニューデリーで開かれる G20 を前に宇宙
emotional stuff. So, very good afternoon to everyone. So, I am Rohit Gehlot and I will be taking the week 6 tutorial of theory of products and processes. So, today's lecture will be a short one as I am having viral flu. So, I hope I am audible. So, can anyone confirm that I am audible?
Yes, sir. You're audible. So, are you saying anything? Actually, it's not audible.
During the time I was saving it, didn't got saved. That was the problem. So, one second, I will just see if it is getting recorded this time properly. So I think it is getting saved now. Like I'll check again and again. I'll make sure. Uh, So I think it is saving. I will check again. So let's continue. So as per the maximum shear stress theory or Gaston-Tresca's theory, so the larger of your these are your principal stresses. So the larger of these three principal strains, it should be less than your yield stress divided by your, any of the factor of safety which you are taking. So it can also be written as, so your shear stress and your tensile stress, there is a relation between these two, so it is around 0.5. So it generally says that this is the general thing which you should be like taking care, like the larger of all these three principal stresses should be less than of your. And one more thing is that if you see in your question, like in your problem, if your shear stress is given, then you should convert it to your yield stress and then do the problem. So let's see, the it's still saving the previous I'll again go to that. And then if we come to the second theory, which is the maximum distortion energy theory. So as per this, or it is also known as von Mises theory, as we discussed, so your principal stresses for detailed, like how they have been came and all, you can visit this week 6 lecture. I saw them, the professors I explained them very well. So so for these, according to this theory, and then there is a relation between for this. So now now the things which comes in our mind, like how the relations between the shear stress and then the yield stress are different. So these are depending upon their assumption which they have taken. So in the maximum, your what we say, like your maximum shear stress theory, the assumption was that the shape was for deriving the things they have assumed it as in a hexagon shape, while in the maximum distortion energy theory it is an elliptical form. And then the relation between the yields or the shear stress and then the tensile stress comes either half and 1 by root 3. So you visit those lectures, and you it will be easily clear to you. So now let's move to the problem session. So 1 second. It is still on, saved or not. Okay, so let's move to the problem session. So the first problem is that there is a homogeneous state of stress for a metal part undergoing plastic deformation is given. So a tensor matrix is being given to you, where the stress component values are in megapascal. So so by using von Mises yield criteria, the value of the estimated shear yield stresses. So firstly, we should know like how this tensor matrix, what the tensor matrix denotes. So these things, like if I write it as a 3 by 3 matrix, then if I read your sigma 1 1, sigma 2 2, and then your sigma 3 3. So these values are your what I can say, known as your sigma x, sigma y, and sigma z. And then sigma 1 2 sigma 21 and other values are known as your tau xy term. So again, so as the theory, as we have to solve it from the maximum distortion energy theory, so the failure or yielding occurs at like the basic assumptions in this theory is that the failure occurs at a point like uh, when that for that particular point the distortion strain energy reaches its limiting value, and then the limiting value is the distortion energy at its yielding point. So from and then what I told that your sigma 11 is your sigma x. So this is 10 MPa. This tensor metric is just a notation, and then your sigma y uh, is your sigma 22. Then it is 20 MPa. Then if I talk about your sigma z, it is sigma 33. So this is minus 10 MPa. Then if we find about tau xy, so these two are your tau xy. So it is 5 MPa. And the other two, this, and then this are your 0. So tau yz. One second. So your tau yz and your tau zx are 0. So now what we will do is that we will use the maximum distortion energy theory. So from this we can find out sigma yield stress values, assuming as we don't need to find your factor of safety, so we will assume this value as 1. Sometimes in your exam it is asked what is the factor of safety. So as here it has nothing mentioned, we will assume it as 1, and then we will find our sigma yield from this, and then we will as in the question it is shear yield stress is being asked, so then we will use this to find out our shear yield stress, and then we will convert from the sigma yield to sigma yield shear stress, and then we will uh, do the things. And one more thing is that here over sigma x and sigma x is equal to a principal stress. So before solving any of the problem, we should be clear that these theory or takes care only the principal stresses and principal strains. So these are not the sigma x, sigma y. So these are the sigma 11 is your principal stresses. Okay, so try solving this by using this formula, and then let's find the sigma yield stress and then convert it to your shear stress at yield point. So and like
So in that equation, actually the numerator is actually shear stress and denominator actually the yield stress.
are you talking about this one?
Yes, sir.
So you are saying that
The numerator is shear stress and shear strength, and the denominator as yield strength. Tensile.
no, I think it is correctly written. So your this shear stress is 1 second. So So your shear stress will be your yield stress by root 3. Yeah, so the same relation is coming. Yeah, it is correct. Yeah. Okay. So like if we try to solve this, we may write it as your yield stress as 20 and minus 20 and okay. So I forgot to mention like in case of in case if your principal stresses are not given, and then there are if and as there is presence of tau xy also, so if tau xy was 0, then these will automatically be your sigma 1, sigma 2, sigma 3, but here tau xy is also given. So then there is a relation between your sigma yield and then so it just it's just nothing but only adding your all the three tau xy, tau yz and tau zx. So these are the same thing, sigma x minus sigma y plus sigma y minus sigma z square plus sigma z minus sigma x, and then just the tau the tau things also adds up. Okay, this is in continued form. So similarly I will do the same thing. So it will be then, as here only one tau xy is present, so rest is 0. So from here, like, we can find out your sigma y value, and then your tau y value will be your this value divided by root 3. Then you will get the answer. So Francis, is it clear? Yeah.
Yes, sir.
Okay. Okay, then let's move to the next problem. So there is a shaft which is subjected to pure torsional moment, and then the maximum shear stress developed in the shaft is this. So one thing is like what I want to convey is from these numerical that the three subjects, which is first one is the your strength of material, then this design subject, and then the third one is your this production part, like forging and the extrusion part. These three are like highly related to each other because they are using the same theories again and again. But generally, what happens, we just like stuck in the notations because everyone has their different notations. Like in the design, some people are using different notations and all, and then we get confused like how to solve these and all. So whenever we like before exam, I like think these three subjects should be come into simultaneously. Like they should be read simultaneously. Like when you are reading the strength of material part, then try to correlate it this with the design part. Like in design, generally they are diameters or like your factor of safety things are being asked. So again, you just see like how they derived these things, because generally the principle like these theory of failures are the same, and then just they are being applied but differently. So firstly, like there are like from this question, like we get to see like it is written that pure torsional moment, and then we need to solve it by von Mises theory. Then the yield and the ultimate strength of the shafts are given 300 and here. So then the general thing is that the students get confused, like will get confused in which yield stress value we have to take, the 300 MPa and or the 450 MPa. So this is also sometimes in the design it comes here it won't be coming, but sometimes in your design problems uh, we get confused like which value we need to take. So then sometimes you need to read properly the problem. So whether it is a ductile material or your brittle material, so which value you will be taking and all. So a lot of things comes in exam to confuse you. Here we know that we have to take this yield value because we know the formula is for yield. Okay, so now let's solve this. So von Mises theory, again the same thing is coming. So we can write the formula as again as here the as this as the shaft is subjected to pure shear. So in the case of pure shear, your maximum and the minimum principal stresses will be equal and opposite. So we can see that there are two stresses are given. Only one stress is given. The maximum shear stress in the shaft is 100 MPa. So we will have to take assumption that your sigma 3 is 0, and then as the tau x and y are not given, so we will again take it them as 0. So this problem will get simplified to like to only two stress problem. So sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square plus sigma 1 minus sigma 3 to the square. It should be less than or equal to your 2 times sigma yield square divided by your factor of safety to the square. So you will have to take assumption that sigma 3 is 0, and then I didn't wrote the terms for the tau things. So then this problem will be very simplified. So it will become as your sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. Yeah, minus sigma 1 to sigma 2. Then this should be or less than or equal to this term. So, and then your sigma 1 and sigma 2 values are 100, and your sigma 2 value is your minus 100 MP. Okay, so these are your 100 and minus 100 because it is a case of pure shear. It is like written that it is a pure torsional thing. So then this we can solve this as, because minus 1 minus then will be, so these things should be less than your, what is the yield is 300. So it will be your 300 square divided by your f square. So as in the problem it was, the factor of safety was asked, so we can solve this. So I hope this problem is clear. Then we can solve this question. From there, like I think the factor of safety is coming around 1.73. Written the answer for this problem, so it is coming around this. So that's the thing is that so you can see like how these theorems can be uh, like in exam, like how these theorems can be asked for solving a lot different things. Sometimes your yield distance will be asked and with the factor of safety will be given. Sometimes your principal stress will be asked. Sometimes from relating to this your principal strain will be asked. A lot of things will be asked. So the just the thing is that we need to take care of. The first one is the we should know the theorem thoroughly, and then the second thing is that the unit should be same, because a lot of problems come when we don't take the unit same, because sometimes these problems get confused. We get confused in solving these. So try to solve this third problem. This is again the same type. So what would be the answer for this problem? So try to solve this, then we may move to the next two problems. So this is a short session today because yeah, I told. So try to solve these problems and then we will move.
Sorry, sir, 500.
Yeah, can you say again? So I'll again solve it for others. So I hope this time it is being recorded. So as it is a uniaxial yield stress of the material is given, it is it is firstly it is a uniaxial yield stress. So it is your sigma y it is given, and then according to von Mises criteria the shear yield stress. So as it is a uniaxial, so again we can say, so we can write so for the uniaxial your sigma 1 will be equal to again your minus sigma 2, so which will be your, so it is the same kind of problem which we were solving previously. So your so I will again directly put this in the formula, so it will be equal to your so this will become your 3 times tau square, and then we can find your sigma shear stress from here, like nothing, I think I'm doing something wrong. So the question is this. Then your tau will be your sigma yield times root 3. So from this we can directly put over MCQs values, and then we can solve this. One way is this, or only the way is like this only. So there is, so from this relation we can put our sigma yield value, and then cross check which one is coming same. Okay. So let's move to the next problem. So in this problem, the state of stress at a point is given as sigma x, sigma y, and tau xy are given. Then we have to solve this from the maximum shear stress theory. You may also try this, and then So like if we see this problem, so as the sigma x, sigma y and tau xy terms are given, so we'll have to convert these we will have to use this to find the principal stress values. So the formula is like again for the tau maximum, it should be less than or equal to your tau yielding by your factor of safety, and then your tau maximum is your sigma maximum minus uh, sigma minimum divided by 2. So this should be less than or equal to your, and then this, there is again a relation between these two. So now for finding the sigma 1 and sigma 2, so we know that sigma 1 comma 2 can be written as sigma x plus sigma y by 2 plus minus root sigma x minus sigma y by 2 to the square plus tau xy square. So from this we can find sigma 1 and sigma 2. So sigma 1, sigma x is 100, sigma this is then both are 40. So we can write it as sigma x plus sigma y by 2 plus minus plus minus sigma x minus sigma y by 2 to the square. So this was also 40. So this will come as 140 by 2. So this will come as 140 by 2. 70 plus minus root 100 minus 40, 60 by 2, it is 30 square plus 40 square. So this will come as your 70 plus minus 50. So sigma 1 will be 120 and sigma 2 will be 20 MPa, and then your sigma 3 will have to take it as 0. So this will be your sigma 1 and this will be your sigma 2. And then from those, so your sigma 1 was 120 comma 20 comma 0. These are the sigma 1, sigma 2, sigma 3 values. So now we will have to take the maximum of those. So sigma 1 minus sigma 2 by 2 is 120 minus 20 by 2 comma 20 minus 0 by 2, and then we will have to take 120 minus 0 by 2. So we will have to take the maximum of all these three. So we can easily see the maximum will be your 60, which is your sigma 1 minus sigma 3 by 2. So we will take 60. Now we will solve this problem. So our 60 should be less than or equal to our sigma yield value is so it should be less than or equal to 300 by 2 times our factor
So
of
why did you take the sigma 3 instead of sigma 2?
because sigma 3 is 0
Okay,
because
for minimum
okay.
value. Okay.
So 60 should be less than or equal to 300. So from here we can find our factor of safety, which will be around 2.5. Okay, so I think it is clear, right? Yeah.
So if it is actually a plain problem, then there won't be stress in the third sigma z, isn't it? So can we take that sigma z as the minimum value?
Yeah, then we can, if it is mentioned that you have to constrict yourself to 2D, then we will take only sigma 1 and sigma 2. In that case, our maximum value would be like 50. Okay.
So if only sigma x and sigma y given, then can we assume that it will be a plane problem? I mean, if it is in a gate or anything.
So generally, what happens in exam, like they will put these problem deliberately so that you took it as a 2D problem, and then but generally try to take all the three stress values, elsewhere you will get a negative mark, because the other, if you will calculate the value from 50 MPa, then that will also be in your solution ABCD, like in your MCQs. So generally try all the three stresses. That is the rule of thumb. If we strictly they have mentioned that you will have to constrict yourself to 2D, then only take two like stresses. Okay.
Okay, sir.
Okay. So then let's move to the next problem. So there is a solid cylinder of diameter this and height this, which is being reduced to 50 height by forging between two flat dies. So we need to find out the change in diameter. So this is we just need to solve it by the principle of mass balance. Or there are three principles, like there is a momentum balance, mass balance, and then there is energy balance. So we just need to solve this by mass balance. So it is very simple problem, but still sometimes in the exam these kind of problems are being asked to check the level of understanding.
So one more doubt, sir. Actually, the sigma one and sigma two will be the maximum value, and the sigma z is actually stress in the z direction slip. It's actually not the principal stresses in it. So can we actually take the sigma z as principal value? Or if the sigma z is zero, then does that mean that the principal z value and the principal set value in the principal plane will be also zero?
Yeah, as it is not mentioned, that's why we have taken sigma your 3 as 0. Okay. So if in the problem it has been mentioned like sigma x this, sigma y this, then sigma z is this, then we will have to generally it won't be mentioned, because else the problem will be very complicated and it will take more time to solve. But generally, like these kind of problem in which two of your stresses will be given, so from that you can easily solve, because in the exam in the gate there will be no calci will be given. So calci is like if you will solve it by it will take, if it take around 5 to 10 minutes. Generally the rule is that for a 2 mark question, generally the problem can be solved in 2 to 3 minutes. So they design accordingly. So generally it won't be asked, but if it is given that sigma x, sigma y, and sigma z is also given, then there will be some trick will be given, like there will be some correlation, or something will be given which you are not able to see, like how it is being solved easily. So if the problem seems very big or something, like a lot of things are being given in the problem, then you just see like there will be something some concept or funda is being asked, like you can solve by using that concept the problem in 1 minute, or like less than that, if you know that concept. So generally the problems are designed such a way only. Okay.
Okay, sir. So so actually, will there be a principal value in the z direction? I mean, we can only find out the maximum minimum value only, sir, isn't it?
Yeah, yeah, right. So
There
if
won't be a third value. There won't be a third value, sir. Principal
sorry,
value.
yeah, can you repeat the last line? I just didn't came here.
Actually, the sigma 1 and sigma, we can only find the stresses in the principal plane as three values, two values, isn't it? For sigma.
Like what has been taught to you is like we can find only sigma 1 and sigma 2, but actually we can find sigma 3 also from the metric system and all. but it is very complicated and all. Like generally we use MATLAB and all to find out all these three values, or there are formulas are also present for for the three system and all, but this is not in your present study scope. So that's why I just told that mm, uh, like these kind of problem will be given in which sigma x and sigma y or like two stresses will be given. But yes, there are problem. Yes, there are if there are like sigma x, sigma y, and sigma z are given, tau xy, tau yz, tau zx, all the three are given. Then also we can find sigma 1, sigma 2, sigma 3. You can search some research paper also on this, or you can see some good book also, like in which but that is not like required at the current level, because this is not in your syllabus, as well as these things won't be asked. But for the future, like if you do any masters or all, if you go for higher studies, then surely you should know these are done and they are being solved. Yeah. Okay. So at
Yes,
least,
sir. Understood.
okay, okay. So this is a simple problem. We just need to do volume balance. As it is a cylinder, so we just need to equate the volumes for the both the things equal. So firstly, the diameter and height is given as 20 and 100, and for the second, after the reduced, it is the height is given as 50, and then we need to find out the diameter. So we just need to equate it as like 20 square times 100 equal to d square times 50. So from this we can directly find the diameter, and then as it is like the change in diameter is asked, so we can find out directly by d2 minus d1 by d1 by 100 times. This is a simple problem, so you can solve it in your free time. So the answer will be around 41.4 something. Yeah. So I didn't made the presentation extensively. I just made it prepared this few one 30 minutes before the studies class, because I wasn't well from some time. So these are the things which I wanted to cover, so that in the next class we will be taking extensive class. So but still we have a lot more time, so we can discuss anything for 10 to 15 minutes, and then we may wrap this session here. So Francis, anything which you want to discuss, we are ready for I am ready for discussion, any kind of thing.
No, sir. I will go through the slides, and if there is anything, I will tell in the next class.
Okay, Francis.
Okay,
Yeah.
sir. Thank you, sir.
Okay, thank you, Francis. Yeah. Okay, then let's wrap this session, today's session, and in the next week, it will be. I will try to have around some extensive session, and I will also try to share some of these notes for these products and things, this forging and uh, extrusion part also, by the end of this 8 week. And then finally the welding is being taught from the week 8 to week 12. So I will also have some brief notes for those, so that so it may be easily covered in covered in one day. Okay, so let's meet then next week's, Francis. And
Okay, thanks, sir.
okay, Francis. Yeah.